Everyone having a good day so far? A good week? Surviving? Yeah, everyone getting through? Good, good. I'm glad to hear it. Hey, did anyone go to the Black Panther comic book seminar talk yesterday? Yeah, I was really looking forward to it, and something came up kind of last minute that kept me from going. I'm just kind of curious how it went. I think that's a really cool project that they were working on, and hopefully it was received well. Why do you doubt that? Okay. Okay, well, today what we're going to do is we're going to continue our exploration of computer programming a little bit by talking about animation and sound effects, okay, which is pretty cool. This is going to be a large conversation over the next 4 or 5 weeks or so, but we're going to start it today. As a not-so-subtle reminder, you have a turn-in next week, okay? If you go to Canvas, I reorganized the module a little bit. I don't know why I initially put this assignment inside of the Week 11 folder, so I apologize for that. But it's now been placed correctly in the Week 9 folder. Let's go check it out real fast. All right, so if you run over into modules, there it is, Week 9. Okay, that's what we're building towards. And if you look specifically towards the requirements for this next big turn-in for your interior scene, yeah, there's some stuff in here that we need to make sure that we kind of check off the list. And I really do see this as a completion list for this project. So, of course, all the art assets should be done. Texture mapping should be done at this point. And we really should be spending the next 7 days on doing everything down below. Okay? So you need to have a simple main menu that allows the player to start and exit the game. We've gone over that already, right? You have depth zones that respawn your character. We've had that for the last 3 weeks. Some 3-player challenges, and 2 of those challenges must require some sort of coding element in order for the player to successfully achieve the outcome of that challenge. We also need to have a clearly defined player experience outcome, or a player experience goal and objective, And we need to be able to communicate to the player when that objective has been met, okay? We also need to activate through code 3 animation clips and a couple sound effects as well. We're going to go over the animation and sound effects component today, okay? And it should be pretty fun. When you're done with this, you're going to be building an app. Please make sure that you submit a Mac OS X build of your game. If you submit a .exe, it's no going to worky.
Did you get the one I sent you? Did it work?
Excuse me. I haven't looked yet. I haven't had a chance.
I was concerned because on Windows, .app files don't register as programs.
It's a folder, right?
Yeah. So I wasn't sure, so I just put it in a zip. I put it in its own zip file.
We can look during lab, but I'm very confident that it's working.
Okay.
Because it has been in years past. Okay. All right. So we have a couple things that we're going to do today. So let's get out of here and jump over into Unity. And let's just kind of revisit where we left off. And I want to close the door today. We have a construction crew that's putting a door on our Performing Arts Center. I don't know why they're putting that door on there, but they are. All right. Okay, so this is where we left off. We got all our UI, our counters in there. We're starting to pass variables from one game object to another. It's starting to kind of feel, if you will, like a real game, which is pretty exciting, right? I know in many cases, I'm really happy that I closed the door just there, right? The sounds of construction. And, so this is always the really exciting part of our game development pipeline. When we start plugging all this stuff in, and now it's starting to behave a little bit more like a real game, okay? We hit the coin, it disappears, we register a point, we walk off the edge, we lose a life, and we respawn back inside the middle of the map itself. Mission accomplished, right? But we need to start adding some other elements into this to start making it feel really more like a cinematic game experience rather than just a simple little demonstration as we have today. So I wanted to start off our class today by exploring just a little bit sound effects, okay? And it just dawned on me that I didn't copy the sound effects that I needed. And if you'd like, Let's do this. Oh, come on. I did put them on here, right? If I didn't put them on here, I'm going to scream. Yeah, okay, good. I did put it on here. Whew. The spring sound effect. And in all honesty, I've forgotten. Oh, that's right. I was a little organized and actually put them in the correct spot, but I forgot where that correct spot was. Okay, so I have two sound effects. A simple little whistle. Okay. As we went over last week, a great repository for sound effects and movie files, believe it or not, is YouTube. The YouTube, and I got both of these from YouTube, the YouTube audio library, and I just did a Google search for YouTube audio library. It's got a bunch of stuff in there. Go check it out. It's pretty cool. I kind of felt like I was forced in every sense. It's going to require me to sign in, which I'm not going to do. I think I was kind of forced to go, for this particular example, to YouTube to use their content on a video that's going to end up on YouTube. I wanted to make sure this live stream wasn't taken down for copyright reasons, so I'm using all of YouTube stuff. So I should be okay, as they say. So I got these two sound effect files. One's called Whistle. The other one's called Spring. Right now, they're an AIFF, that's the Apple audio format file. But if you're using .waves, I think even .mp3s work as well. You basically can use any standard audio file inside of your game and get those components back or played back inside the editor itself. Like everything, let's load them in because we got to load them into our game. So I'm going to create a new folder here, and I'm just going to call these audio clips. And let's import some assets in there. I'm just going to grab both of my spring and my whistle, just throw them in, and we're up and running. Okay? Yes? I sure can. You guys want these two little sound effect files? I'd be more than happy to provide them to you. They're not mine, so I can just give them away for free. Say again? They're coming right now. Hang tight. You should have them. You should have them now-ish. Very soon. There we are. All right, I'm going to do one more thing. This is for Vo. Now, Vo, this is going to take a while to get there, but we'll go ahead and get it started. All right, Vo. Okay. All right, let's jump back over into Unity here and start looking at these assets that I've imported into my scene. So once you got them in, you can actually look at them individually, and you can play them inside of Unity, which is kind of fun. It's always a good little double check. Yeah. And the spring one's kind of fun. So I think I'm going to use the spring one for when I touch my little coin. Okay. So that's the idea. I touch the coin, it goes bong. Okay. So we need to start making some relationships between the coin game object and this audio clip. Now, we're going to do this in a pretty intelligent way. We're going to start loading in a couple things, okay? And in order for sound to work correctly inside of Unity, you really need three things, okay? First, you need what's called an audio source game object. And as one might imagine, this is going to be the game object that's going to contain the clip, okay? That has to be attached to the thing that we're going to be interacting with. So in our sense, this audio source is going to be attached to our little coin. Okay. In addition to the audio source, we also need to have an audio clip. So we have the container for the audio clip and then the clip themselves. Okay. The third thing, in order for this entire audio system to work correctly, is that we need to have some sort of listener. Okay. And this listener is often associated with the game controller itself, or the player controller, because we want to be able to have our player walk around the scene, and then when that player gets close to an audio source, the player is going to hear it. So imagine the audio listener kind of like a pair of ears for our player. Okay? When you're working with the default Unity scenes, our main camera automatically comes with an audio listener in it. Okay? Now, I've stripped out the default main camera from my scene file here. However, the rigid body first-person controller, if we look at it, it has a camera, and one of the components in there is the required audio listener. Okay? Now, if the game controller or main camera or whatever, if your scene doesn't have an audio listener, this is a game component that you can easily add in the menu downstairs. Of course, we have an entire section here for audio. I definitely encourage you to go check this out. They're actually getting pretty advanced with their audio system. It's pretty neat. So I would definitely encourage you to look a little bit more in depth on it. Here's that audio listener that I was referencing a second ago. All right. So first things first, we need to look at our coin here real fast. There we go. Okay. So our coin game object at the moment, this is a prefab. So let's add in an audio source, okay, to our prefab. Got to have that source object in there. And once we load in the component, check it out. It has a field here for an audio clip, and that's what we want to reference. Okay, this is what we want to access in code. But since we're going to be using this on an instantiated prefab, we have to do it a little bit differently. We just can't drag and drop an audio clip in there, right? We want to use a little bit of code to get this going for us. Now, our audio source is attached to our coin. Let's just ensure that when we play the game, that what is instantiated into our hierarchy also includes it. I am trying to see, and I can't read today. Yeah, it was over here under coin spawn. Yeah, and I don't have my mouse open at the moment, so I'm going to assume that it's loaded in. We'll have a pretty good indication of whether this is working audioly here in a second. Okay, so let's go over and start looking at the script that's associated with our little coin, because we do have a coin in here called the coin destroyer script that's really driving this entire operation. Let's just go ahead and load it up, because this makes sense, because once we touch the coin, we want the audio clip to play. That's the goal in all of this, right? So it makes sense that this audio command be thrown out and executed in this script, not with the creator script, but with the destroyer script, okay? Because we basically want to play the sound effect right before we destroy the game object, okay? So there's a couple of things in here that we need to do first. First and foremost, we need to reference the game component that we're after, and then of course the clip that we're after as well. So the first thing that we need to do is that we need to reference the audio source game component that's on this game object, right? We basically need to go grab it. Let's do it real fast. So we're gonna start off by making a public variable, public, and this is going to be audio source, okay? And I'm going to name this variable just something simple, my source. Okay, rock and roll. In addition, we also need to make a reference to the clip, the actual sound effect that we're going to be playing in here as well. So we'll make another public variable. This is, as one might imagine, this is going to be audio clip. And I'll just call this, also following the convention, my clip. All right, so we've created the variables. Let's start loading some data into those variables, and the start function is a great place to do that. So down here, we're going to start loading in some stuff. So we need to first get the audio source game component. Okay, so my source is equal to, does anyone want to take a guess at what we're going to do here? So what were the yeah, so we need to get this thing right here, okay? So we're on the coin game object. Now we're trying to access this component in code. We're trying to load it into the actual script itself. What is this thing? Yeah, so it's a component, so we need to load that component. We need to get that component. So all of these things, the transform, the mesh filter, the renderer, the script, the collider, these are components of the actual game object itself. So the first thing that we need to do over in Visual Studio is get that component. Now, since we're getting something that currently resides on the game object where the script lives as well, all we really need to do is just do get component. Get component. What comes next? The carets. Yep. Open and close carets. We're going to put audio source in there here in a second, but I always like to kind of flush out the syntax pretty early on. I put my open and close parentheses, and then my semicolon. Inside the carets, the component that we want to access is the audio source component, right? So we've loaded that audio source component into a variable called mySource. And now we get to do stuff with it, right? The next thing that we're going to do is that we need to load a clip into the audio source itself. Now remember what's going on here. We've just loaded in this component. Now we're trying to get this thing right here, okay? So this is a parameter of the component itself. So I need to get access to that and load some data in here, okay? So here's how I'm going to do it. On the next line of code, I'm going to say my source dot clip, okay? Oops, excuse me. Is equal. I'm setting it to my clip, okay? So whatever we load in the inspector into this variable will automatically be loaded as the audio clip in the audio source game component that we're working with here, okay? I think once you see it in action, you go, oh, I get it now, right? We forgot a semicolon down here at the end, so we got to make sure we add that in there. Okay, so let's test it. Let's save it real fast and head back over into Unity and pray that we don't have any typos or compiler errors. Yeah?
I have a question with audio player.clip equals audio clip. Why isn't it audio clip equals audio player dot clip?
I understood nothing of what you just said. Okay, let's try that again.
One being your word.
Okay.
Your name.
Yes.
Audio player.
So are we talking about this line of code right here?
Yeah.
Okay.
Why
Yep.
is it in that order and not my clip first equals my source dot clip?
Yeah. So we are loading information in. Okay. We're grabbing whatever information is loaded in this variable, which just happens to be a game component. Okay.
The one above it is reverse in order. You've got your name equals what it is, and then this one is what it is equals the name.
No. What it is equals a variable.
A variable.
This is the variable. Yeah. I could go in there and just write the actual, but we're going to plug this into a variable. Yeah. Yeah, because remember, this here is an audio clip variable that I'm storing here. Okay. Let me show you what this looks like over in the inspector, and then I think you'll go, oh, I kind of see where we're going here. Okay. Sometimes you have to see the complete work of art, if you will, to understand it. Not that this is a work of art. Okay. So I have no compiler errors. If you look over at the Coin Destroyer script now, check it out. Of course, we have our game controller. That was from earlier. But now we have another public variable called mySource, and it's data typed to an audio source game component, right? And we also have an area in the inspector where we can drag and drop a specific sound effect file. So we've kind of made it generic. We can swap in and out all these sound effect files without having to return to the code and change what we've hard coded in. It's a little bit more flexible this way, if you will. Okay. Now I can change the audio clip in the editor versus having to go back over into Visual Studio and do it manually in code. Okay. So if we were to play the game as is, now I can't. Without my cursor, it's hard. I would be able to select in my hierarchy coin spawn, and I can't do that right now because I don't have my cursor. But you would see that it's grabbing the correct audio source game component in here. The thing that we need to add is the clip. Okay. So let's just do it real fast. And this is what's really kind of fun about working in this system. I'm just going to grab my audio clip, and I think I wanted the spring. Yeah, we'll just load it in. Boop. There we go. All right. So things are starting to flush out the way we want. But at the end of the day, we still have a little bit of a problem. We're not actually doing anything, right? We're not actually calling the command to fire off and to play the audio clip. We've loaded in the correct audio or the correct game component. We've loaded in the clip that we want to play, but we're not actually firing off the command that's fundamentally going to play it. Okay. Now this is where we can get really complex or really simple. I think what I'm going to do is that I like to have everything kind of saved into a whole series of functions. But basically, this is what we're going to do. Where is it? Okay, right here. So before we destroy the game object, we want to play our audio clip. And it's really easy to do this, right? Because now what we basically need to do is access the game component, which is called my source. So I'll copy that. And the command is simply .play with a capital P. And we need to make sure that we have an open and closed parentheses down there at the end to fire it off. Okay? So this is the name of the variable whose information is loaded here. Okay? We're playing whatever clip is associated with it, because each audio source can only load in one clip.
Quick question, why isn't it my clip instead of my audio source?
Down here under play?
Yeah.
Well, we're actually just telling the audio source to play a clip. Play the clip that's associated with it. Yeah. So we're not trying to access a variable. We're just saying, hey, hit the play button. Yeah, and we only want to hit the play button when this particular event happens, which is when we touch our little coin. Let's save the script, go back over into Unity, and if we're lucky, let's play the game. We'll go touch the coin, see what we get. Mission accomplished. Did you guys hear it? Yeah. I'm still touching the coin, by the way. Yeah, it was. I ran into it, and then I think if I remember correctly, it doesn't immediately die. Yeah, it dies after a second. Let's just get rid of that. Save that. Go back over into Unity and see what we get. Now the coin is going to disappear immediately. Was that me or is that someone else? That may have been someone else. We all working on the same sound effect, but I think it's working. Let's see if it is. Oh, I think it destroyed it before I had a chance to play. So let's go. Let's put 0.05. I think float values can work in there for time, but we'll find out. Yeah, no, it needs to be a whole integer. Didn't like it, so let's put this back. Oh, and I forgot a comma. Let's try it again. Yeah, it has to be an integer. Fine. Put that back to 1. All right, let's try it again. There it goes. And then it's destroyed. Yay! Okay.
The sound, though, if it's like
So,
5 seconds for your destruction, will it keep playing it, or is it a
let's find out.
instance?
Let's put this to 3 seconds. That way we don't have to wait so long. It should play it just one time, but let's find out. Just once. Yep. Yeah, animation clips will loop, forever until we tell it to stop. But I believe audio clips almost by their defaults will only play just one. Let me see. I don't think there's a property in here that tells it to play over and over again.
The source has a loop option.
Where do you see the loop?
It's not there. It's in the audio source on the object.
Oh, on the actual game object itself. Got it. Yeah. There it is, yep. Now I want to turn off play on awake too. I wasn't necessarily getting that, but that's a good thing just to have off in general.
Is there any way to have the sound play at the exact same time as another function is happening?
Yes?
Instead of like right before or right after?
Yeah. There's a wait for seconds command. So, yeah.
Okay, because in my
So, good.
GCOM, I have an issue like a lag happening when the animation happens and the audio never ever plays at the exact same time.
So here's a good problem to solve, right? And this actually kind of almost as if you're reading my notes a little bit, which is good. Because I don't like to have a command like this inside of another function, okay? Especially if we're trying to maybe extend the functionality of playing a clip, like we'll have to add a wait for seconds or something like that. You know, maybe a better way of working is to extract it from, you know, just by calling the command and write its own function, okay? So I'm going to make my own function, and I think I'm just going to call this just simply play sound, okay? Open and close parentheses, open and close curly brackets, and now I'm going to paste in that command, okay? So at the very least, we're still going to get the functionality that we had before, okay? Now, instead of calling that line of code, I'm just going to call the function. So I'll copy it, make sure I put a semicolon out there at the end. So now, when I touch the game object, it's just going to activate the function, and that function just happens to play a sound effect. But as Indigo was asking, it's like, can we add a couple other things in here? And maybe this is a great example of where, yes, we can add a couple things in there. One of the cool things about working inside of Unity is that their entire scripting API is wonderfully documented online. So I'm just doing a Google search for Unity Scripting API, okay? This thing right here. This is basically the scripting manual, okay, for the entire game engine itself. I have this bookmarked because I go to it that frequently. It really is a never-ending treasure trove and how they hook in to all the rest of the Unity code structure itself. So let's just, I remember it being wait for seconds, but I have some questions as to the syntax, and I want to be very, very, yep, here it is, wait for seconds. Yeah, check it out. Wait for seconds is the command, and then in parentheses, we put the number of seconds that we want to pause. So, so it's wait for seconds, okay? So in this one, wait for seconds. And how long do we want to wait to play it off? I don't know, let's just pick a number. Let's do 3. Okay, that way the cube should be, or the coin should be disappearing at the exact same time as the sound effect is played, right? Hopefully, we'll find out here in a second.
Well, didn't that not work last time when you destroyed the coin and played the audio? The audio didn't play because the coin disappeared?
Oh no, my audio played just fine last time. Now, why is this not working? The error expression denotes a type where a variable, valuable, or a method group was expecting. So I messed it up somehow. Oh, I think I had to have yield in there. Is it yield wait for seconds? And maybe yield wait for seconds. I don't remember off the top of my head if I had to have return. Let's do this. Wait for seconds. Unity. There we go. Like I said, it's not about knowing everything yet. Okay. So you have to have yield return new. Let's try that. Go back into Unity now, see if we have any compiler errors. Void, play sound, it's not liking this at all. But this is how I have to do some work here. Frames. 3 seconds, 0 frames. I believe that's what it's saying. Let's see if there is an example here that gets me close. Let's do this. Let's get rid of all of that. I may have the wait for seconds in the wrong spot as well. Yeah, I have it. I don't have it right. Yeah, I don't have this written correctly. It's not integrating into this line of code here. So I'll have to do some more investigation, but this is the path that you'd probably want to go down if you're trying to have it pause for a second before this function or the sound effect is fired off. All right, I'm going to strip that out of here. Save my script, go back to Unity. All these compiler errors should go away, and they do. Life is good. Let's just do a quick double check, make sure things are working the way I want to. Nice. Then it goes away. Rock and roll. Wonderful. It works. So that's as easy as it is. It really is. Can be quite simple. Okay. You don't necessarily have to call sound effect clips at an action. If you wanted to have music in there, okay, the music still needs to be associated with an audio source game component. So that's going to have to be attached to some sort of static element inside of this world. Okay. So it's pretty cool. I definitely suggest you take a look at it. There's a lot of stuff that you can do with audio, and this is a real simple example of how you can start accessing and playing those audio clips when an event happens. Okay? Pretty cool, huh? All right. All right, so I wanted to spend the rest of our day today talking about animation, because the animation is going to be a critical part of our entire structure going forward. And this is going to be just part one of about part 5 of our conversations about animation, because working with animations, as one might imagine, is a big part of the game development pipeline. If you think about it, characters, enemies, doors, turrets, I mean, all these things are movable objects that are going to be driven by an animation clip or some sort of animation event. We're going to start talking about animation clips today, which are little prepackaged animations that are going to be saved to a game object inside of our scene. Either next week, it's probably not going to be next week, but I think maybe the week after. We're going to start talking about more programmatic animation, where instead of creating a clip, we're going to create a range, and things are going to be moving within inside of that range. You're going to find that animation clips allow us to create some very complex, compelling animations quickly, right? It allows us to work inside of a traditional, DCC environment, like a Moto Maya environment. Anything that we animate over in Maya or Moto can very easily be transitioned over into Unity in the animation clip. We'll talk about that a little bit later. Yeah.
So if we have like a security camera, we want end result would be nice to follow the character. Would we do that animation and then somehow the programming would track? Or
yeah, I think with something for a security camera where it's just doing this,
right,
okay, and then boop, it looks at the player and then tracks the player. That's going to be more programmatic movement.
Okay.
Yeah, and we'll talk about that in the future. Yep. Animation clips, the only kind of negative part about working with animation clips is that if you have a bunch of them, they can really quickly balloon your project file size pretty quickly, because it's actually saving. Animation clips require a little bit more data than our regular script would, scripted movements. So we've got to be careful with it. Not everything is an animation clip, but some things are.
Is there any like packaged animation clips where you just plug them in and it automatically just takes this object and
No.
makes it too easy, huh?
Yeah, too easy. Yeah. Maybe the answer, maybe. It depends on the animation you're applying them to. Yeah.
I was talking about super like a door opening.
Well, we're going to go over that. We're actually going to create some animation clips in Unity today, right? Not everything has to be complex. Sometimes something as simple as a door opening, those are simple things that we can do inside of Unity. Yeah.
I think there's kind of ways to, because on Unity,
Like I said,
they sell like people movements, and then you
Yeah.
can tweak it.
Like I said, it's the answer to the question is yes, you can, but it's not easy, right? You have there's some yeah, it's not easy. You can do it, right? But it's not something as simple, drag and drop, you're out the door in 2 seconds, right? It's yeah. It takes some work.
If it was easy, everybody would be doing it.
That's very true. That's very true. All right, so let's start working on our next big project here, or our next big component of our little game, and we're gonna make a door. This is just gonna be a simple simple door opening and closing, okay? So the first thing that I want to do is physically create a door, because I don't have a door yet on my entire game. So I want to create a door, and then, you know, as with everything in the game development world, we have to kind of prototype how it's going to work in our mind or maybe on paper first before we start building it. So in my imagination, when our player gets close to a door, the door is just automatically going to open, right? So if they want to, so we need to have some sort of detection system in there, right? Because as we walk up to a door, whoosh, the door is just going to open, and then as we go through the door and exit, maybe some sort of detection zone, the doors are going to close behind us, right? So we know that we're going to need maybe a wall, a couple game objects for doors, and then some sort of detection system that allows the computer to track whether or not the player has entered or exited this detection zone, right? Now, we've already done something similar with our detection zones with our colliders, right? We were using colliders for our death zones earlier, and we actually activated them as triggers, right? You guys remember that with our death zone? The moment that we touched the death zone, we triggered an event, and that event respawned us back to a defined location. Well, we're going to do something similar. We're going to continue to use the power of this triggering system to detect when the player is within a certain range of the door itself, okay? Let's go ahead and start prototyping and plugging all that stuff in together. The first thing that we need to do is to create a little door. All right. I'm going to turn off my UI just for a second, just so I can work a little bit faster here. And I think I'm just going to create, believe it or not, some simple cubes. This is going to be my marvelous door system. Let's see, I want my walls to be pretty high. I want them over here. That's a little too close to the player. Okay, there's one wall. Okay, just pretend with me. Okay, we're allowed to pretend in this class. All right, so let's just make that 8 along the X. I'm going to duplicate that game object and then transform it to the -8. It's on the exact opposite side of my little environment here. Okay, now I'm going to need, so let's just name these as we go. This is going to be wall left, and naturally his friend down here is going to be wall, right. There we go. And let's give it a fun little color. I can't remember. Here, we won't be red metal. I'm going to make it a nice new material here. I'll call this one just blue. That'll do. And that material gets assigned to both of our walls. And we're up and running. Ha! Looking good. Okay, so we got our walls done. Now it's time to go. Let's play it first. You always got to play it as we build it, just to make sure that life is good. Yep, life is good. Oh, our coin's in the wrong spot. So let's change the respawn location for our coin.
Hey, Pat, is there any way to, when you're in Visual Studio, just like save off a copy of the script, the CS file?
In Visual Studio.
I don't have my build with me just because I couldn't strip it down far enough for it to be feasible. I just wanted to keep getting out the script.
Yeah, I believe you can just do a file save as for that script. Yeah, because then you can just export the script as its own .cs file and put it wherever you want. Okay, so let's make our silly little doors now. As one might imagine, they're just going to be some cubes, okay? And let's start scaling these objects up. I'm just being a 3D modeler here. There we go. Now, there are better and faster ways of doing this, but I'm just trying to make it easy and simple. Whoa, disaster's happening outside. Should we run out and see what's going on? Probably not. They'll be all right. I'm sure they're tough.
You said they're building a door out there?
They're built. I honestly don't know what they're doing, but it appears as though they're building a door. Repairing? I think they're replacing it, yeah. I was joking around with Grant earlier before class, and never have I ever once, because I've been through that door 1,000 times, right, over my tenure here. I've never once said, hey, we should fix this door, right? Hey, this door is broken. We're getting a new one for whatever reason. I don't know why. All right, so this is the beginning of my actual door. I'm going to duplicate that game object. And let's see, it's a little bit too small. And again, I'm being a 3D modeler because I'm super dorky like this. Okay, so this guy is 2. Okay, so let's duplicate it. And his duplicate friend is going to be -2. And it's still not big enough. Okay, I am no longer caring. They can actually intersect and go through each other for our purposes. Okay, so there it is. There's my impenetrable wall. If we go through, dun, 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 it stops me every step of the way. So we have some things in here that we need to fix. Okay, so this is where we are. At the moment, we need to add in some sort of detection zone for our doors, right? And so, you know, since I want that detection zone to influence both of my doors, okay, I'm going to create a small hierarchy inside of my scene itself. So let me stop my game, and I'm going to add an empty game object into my scene. Let's just name these real fast. This is door left, I think. Yeah, door left, and its friend downstairs. This is door right. Okay, rock and roll. So here's my 2 walls, my 2 doors. I'm going to add an empty game object now. That's going to be kind of like the controller of both of these doors, okay? And I'm putting it in a small hierarchy so that the detection zone is kind of influencing and is controlling both doors. It's a representation of both doors, not just a single one, right? So let's just call this door group. Rock and roll. All right. And I'm going to drag and drop my 2 door game objects into the group. Now, as I mentioned just a second ago, the group is where I want to create some sort of collider that will act as a detection zone for when my player enters and exits the door area. So let's go ahead and add that component. And I'm adding it to the group, not the individual doors, okay? Just the group. So add component. It's under the physics section down here at the bottom. And I'm simply just going to use a good old-fashioned box collider. Our friend, Mr. Box Collider. There we go. Sorry, I was having a day. Just having a day. Okay, so let's get this working the way I want it to. I'm going to center this up. I want to make it a little bit taller and a little bit wider along the z-axis. Okay, and I'm going to position this generally in the middle of the door. Yep, that looks almost pretty good. That's a whole lot better. So now we get to play around with how far the player needs to be to the door before the door is triggered. Okay, and that's one of the reasons why I like this. I like using colliders, is that we're not hard programming in a numerical value. We're just interactively doing it with these cool colliders. Something like that. That's pretty good. Rock and roll. I'm digging it. This is going to work, I think, quite wonderfully. As a prototype, let's see how it goes. All right, so first things first, we need a new script, okay? And this script is now going to control the doors themselves. And like everything inside of our game development pipeline, we need to test to see if we're actually influencing and triggering and activating this collision system as we go, okay? I think it's a really good practice to create a whole bunch of states within inside the game and test whether or not that state is true or false. So let's create our script, and we're going to attach it to this door group here itself. All right, so new C# script, and I'm simply just going to call this door controller. I'm not being super creative with my names for all my scripts. Let's go look at this in Visual Studio and get to work, because there's a couple things in here that we need to do. The first thing that we need to do, cancel. All right. I'm going to get rid of some of this commenting in here because it just kind of gets in the way. The first thing that we need to do is that we need to create some sort of state that we can test against. Inside of my little detection zone, I want to know very directly, am I in the trigger or am I out of the trigger? Okay? So that trigger is going to be an important part of this entire system. So let's start writing the function here that will allow us to collect that trigger information. So trigger on, or a void on trigger enter, okay? Get rid of all this jazz for the time being. So trigger or void on trigger enter. We don't need that private in there. On trigger enter, okay? Now, earlier, we were testing against the tag of the player. Does anyone remember how we did that? Because we did this with the coin, right? Because we only want to register a point when the player, or the game object that's tagged with player, collides with the coin. Do you guys remember how we did that? We used an if statement. We asked a simple question inside of our scripts, right? So let's do something very similar again, okay? We need to write a question, and I always like to create the structure of my question first, so pardon the housekeeping. So we need to write a question in here. So if a game object that's tagged with player, perhaps, touches the collider, then something happens, right? Let's figure out how we're going to do that. So much like we did with the coin, we need to collect some collision information, okay? We did that previously with a variable, and we did that up here inside the name of the function, okay? So I want all the collider information, okay? So any collider information we're going to store into a word called myColl, okay? That's just a variable, and we're loading, the data that we're loading into that variable is collider information. So whatever collider touches this, this little green box, we're going to save that info into the word myColl. And now we want to access it, okay? So now we want to say if the stuff that collided with me, so myColl, gameObject.tag, is 2 equals player, oops. Okay. Then we do something, right?
The mindful thing is basically as if the script is talking about if what is colliding with me is.
Bingo, you got it. Yeah. And that's exactly how I kind of make sense of this in my brain. If what's colliding with me has been tagged with my player, do something. Okay? We've been doing a lot of this to access the debug console, the debug line in our console. There's another great way we can do this, and you see this often out there online. We can kind of truncate this, shorten this a little bit to simply print. Okay? Now print does fundamentally the exact same thing, but we need to do some stuff to it, right? Okay? Basically the exact same thing as a debug.log, okay? Instead of writing debug.log, we're writing print, okay? Now currently inside of my game, and I think it's in one of my other scripts, and I apologize, we are writing something to the console already, and it's under character controller. Let's see. I just want to turn that off. Yeah, here we go. We don't need this anymore inside of our character controller. I think that's the only thing that we're doing. Okay, cool. Let's go back to door controller. So if whomever passes through my collider is tagged with player, print the log, you enter the collider. Okay? Let's save it, return to Unity. Pray that we don't have any collider or compiler errors. Life is good. Let's see if it works. Uh-oh, wait a minute. I'm hitting the collider. I'm not actually passing through it. What did we forget to do on our collider?
Put it inside out.
Is trigger. Okay. Now we're using Ontriggerenter. We need to transform the collider into a trigger, which is basically going to stop it from being an invisible wall, but it's still going to detect when something crosses through into it.
So are colliders like this sort of how invisible walls are programmed in games?
Yeah, this is exactly how invisible walls are done.
So I've noticed is trigger likes to break things or like mess up.
It's all contextual.
Okay.
It's all contextual.
When used the right way, because I've noticed like geometry when isTrigger is on.
Uh-huh.
I'm not sure if it's always triggering something. If there's a collider and everything on it. Is it telling it like isTrigger? It has to trigger to hit the collider.
Like I said, it's all contextual. We'd have to look at the specifics of your scene and see what has the collider, what's triggering. I mean, it's very, very specific to your game build. Yeah. Yep. Okay, so now that isTriggered is enabled on our collider, let's go back in and see if we did it. Now, I have a null reference. Oh, I think I broke something when I deleted that game. That's okay, but we'll still manage, because over in my console, let's see, did it actually trigger it? Thought I saw one line here where it was different. A value was found where an object instance was required. Here, just for, and I think I know why it's doing this, because I turned off my canvas. Does that null reference go away? It does. Okay, great. All right, so problem, big time problem. I am not detecting collision yet. Thank you. I forgot to do that. I always forget to do this, right? I always forget to load in the script on the object itself, because right now I didn't make an association between my script and this group. So let's get door controller on there. Duh. There we go. Now it will do something. Thank you. Here we go. Let's try it again, and hopefully, there it is. And I can see down there in my debug console, you entered the collider, so I know that I'm actually detecting collision between my game controller, or excuse me, my player controller, and this on this collision zone. So let's do something with it, right? I'm a big fan when it comes to working in code of infusing a little bit of logic in here, right? So this is now useless. It was just a test, right? Just to make sure that this entire system was working. But ultimately what we probably should do here is create some sort of state, some sort of Boolean that we can now ask a question against, right? Is the door open? Is the state of the door is true or false? And if we meet or don't meet that condition, then something else can happen, right? Using these logic statements is actually a really powerful, powerful system of allowing you to craft questions, okay? So I want to create a Boolean, and I'm going to do this at the very top here. So let's just make a public variable. Of course, it's going to be Boolean, and I'm just going to call that Boolean door state, okay? The first thing that we need to do when the game starts is set that Boolean to, set that Boolean to something, and we're going to put its state to false. It's the first thing that we do when the game starts, is we set the condition of the Boolean, okay? Now we have something that we can ask a question against, right? We have a switch that we can flip up and down, okay? It's on or off. Right now it's off, okay? Now when we enter into my collider, I want to flip the switch on, okay? Which will allow me to ask an additional question that's basically going to be, hey, if the switch is on, do something, right? So once I walk into my collider, I'm going to change the switch. I'm going to flip it to true, okay? Which will allow us to ask questions against that if we so choose. It's a good practice to get into. Okay.
Where did you start the Boolean for door state?
Yep, so we just got to make sure that we declare it, create it outside of any function. That way it can be a member of any function, which we want it to be, right? Just start right up there at the top. Now, if we flip the switch to true, there's got to be something that switches the flip back to false, right? What's gonna put the state back to false?
Trigger exit.
Trigger exit. You got it. So when we enter into the trigger, it opens. When we exit the trigger, the flip gets down. Okay? So now we need to have another function. And I'm just going to copy and paste this entire thing because we can almost take it in its entirety. So it's not going to be Ontriggerenter, it's going to be Ontriggerexit. We're really not going to ask a question against the collider information because we don't care what closes the door, right? You know, if an enemy runs into the collider and the door is closed, nothing's going to happen. We don't care, right? We always want the doors to be closed. We always want them to open for a specific object. We don't care who closes the doors, right? Well, in this example, we don't care. So I'm going to strip out some of this. So we don't need to create a variable and capture information. We certainly don't need to ask a question against something. But what I do want to accomplish is flip this back to false. Okay, so this is starting to look pretty good. We enter the trigger, it flips to true. We exit the trigger, it flips to false. Let's test to make sure that we're exiting the trigger correctly, okay? And I'm just going to, because we tested the entrance, we never tested the exit. So you exited. Let's just test it real fast. Let's go back over into Unity. Okay, now I'll be able to see if that switch is being flipped by watching that little checkbox over in my inspector. You'll see it actually go on and off when we both enter and exit into the game itself. So that's good visual confirmation. I'm not going to go through like printing something to the log just to see it. We'll see it there. Yeah.
Is it cheaper on resources to do the animation inside of Unity with like movable components or like bring in pre-rendered from Moto?
Yeah, it depends on what's being animated. We're animating just a cube, so the resources are going to be pretty light either way.
Say you had fully modeled doors, right? Hinges and everything, and it goes up, like slides up and down or slides left and right.
You know, I'm not sure. I haven't really done a comparison in the data resources for something like that, but take a look at it.
Okay.
Yeah, you can see the size of the animation clips and start doing a comparison. Okay. So let's get back to our states here and test whether or not we are entering and exiting our game. Okay? So we enter the collider. Oh, that flip got switched, right? Now, I'm just going to backpedal and exit the collider, and that switch gets flipped again. Can you guys see the switch getting flipped? It's going to be hard for me to do it while the game is playing. But just watch over in the inspector. You can see the little checkbox under my door controller script kind of going on and off. Okay? It's a great... Yeah, it's a great way to test if that state is enabling and disabling. Yeah, go ahead.
While you're playing the game,
Uh-huh.
press escape. You can free your mouse from the screen.
Oh, gosh, there we go. That works pretty well. Thank you. Yeah, now we can go ahead and do it. Okay. All right. So yay! The first part is done. We've created a wall, we've created a door, we've created some sort of detection system around the door. We've created a script that allows us to check to see if our player is crossing in and out of this detection. We've created a state for this detection system. We have 80% of the programming for our door done. The last part is actually creating the animation that's going to open the door, right? And this is where it gets a little bit tricky, okay? Because there's some funky terminology going on inside of Unity. And then if the developers at Unity are listening to me, you should change this. Because it's... No, they never listen to me. No one knows I'm alive. You guys are the only people that know I'm here. Although I do somehow have like almost like 5,000 YouTube subscribers. So I'm convinced like half of them are like bots, you know, from some like Russian hackers that, you know, that have subscribed to my YouTube channel. So I don't, anyways.
There's a way to check that.
Is there a way to check that? I would be really fascinated to see how many of them are just like vaporware user accounts that automatically subscribe to my account. Anywho, so let's get into it. Let's start actually creating the animation clips that are going to be associated with our game objects to open and close the doors themselves. Okay, it's pretty fun. This is where it gets kind of entertaining. So let's do it real fast. Okay, now we're going to put our animation data on the group. Okay, because the cool thing about the animation engine instead of Unity is that the group gives us access to the children as well, which is pretty neat. So we're going to animate the group, but we'll be able to individually control the children of the group, which is pretty neat. So that's an important distinction and something that you want to make sure you underline in your note. We're animating the group, okay? And in doing so, we'll be able to animate each individual door. So let's do it real fast. First, some housekeeping. We're going to load in some windows here that are going to be responsible for the physical mechanical part of animating our doors open. So the first and foremost, we're going to open up our animation window, okay? And this is where it gets confusing, and I apologize. I have zero control over this, right? We have an animation window, and then we have an animator window, okay? The animation window is where we're going to be doing all of our keyframing. We'll see a small little timeline. We'll be able to transition between a whole series of components. The animator is where we're going to be blending between animation clips. More on that in a minute. Okay? So let's open up the animation window, and I'm going to dock it to the bottom part of my interface just so it's nice and big. Okay? So now that we've exposed the animation window, I want to make sure that my door group game object is selected, because, and this is, I like this makes it easy, right? Because in order for us to animate something, we need to create an animator, and I get it, an animator, right? And think of the animator like the brains of this entire movement system, okay? And that brains needs some food, right? It's like a zombie, right? So we need to give it some animation clips for it to control. So we need to give our real animators, some Doritos every once in a while. Throw a Cheeto at them, they'll be happy, right? They're like little mushrooms. Just put them in the dark, feed them some, and they'll be happy campers. I'm joking. All right, so I like that you can, when you hit the create button, it both creates an animator and will help you start creating an animation clip, okay? You don't have to hit the create button, because the animator is a game component that sits on a game object. Let me hit the create button here for you real fast. We're making our first animation. This is an animation clip, okay? And I'm going to call this one simply door idle, okay? Because I need to have one clip where the doors are just kind of shut, where they're static, where they're not moving, right? In addition, I also like to have a subfolder inside of my asset directory that's just called animation clips. There are a zillion ways you can organize it. This is just Pat's crazy way. And I'm also going to create another folder called door. That way, I have a master folder called animation clips. I have a subfolder called door. And what would you imagine is going to go in the door subfolder? All of the door animations, right? Okay? All right, so I've just simply, did I hit cancel? I may have hit cancel. I have a very good track record of doing that. I sure did. Let's try that again. Golly. Okay.
Well, at least all you have to do is
There we go.
the name of the...
Haha. All right. So mission accomplished. Now, I wanted to show this to you because it's really important that we check this out. Okay? So here's the group. The moment I created an animation clip, it created the animator for me. It is a component like any other component. So if you want, you could go ahead and add this yourselves. It's in the, where is it? I forget where it is off the top of my head. There it is.
Can you pin sounds into an animation? Like say you wanted to push something over and it falls off the pedestal, it hits the ground.
Yeah. You'd probably make some sort of function that plays both the movement, the animation clips themselves, and the sound effects at the same time, similar to what we were attempting to do with the coin at the beginning of class.
Like you'll wait for seconds to fire the sound?
Yep, you got it. Yep. Or there's actually some other things in the timeline that will allow you to do that as well, because we can create trigger events on the animation clips themselves, which can trigger a sound effect.
Oh, like
So-
at this mark, play this sound?
Bingo, you got it.
If you use like a rigid body and it's just something hitting the ground, you could use what, when it touches the ground, make a sound.
Yeah, there's a lot of different ways to skin this cat.
I tried that, and if something gets like caught in geometry and does that thing where it just kind of like jiggles on the ground, it'll play that sound.
Yeah.
It goes full Gary.
I think if I remember correctly, and I don't remember the actual command itself off the top of my head, but I remember seeing somewhere where you can tell it to play once, play your audio clip just once. Yeah. In code, and then I think you actually destroy the actual clip itself, so it forces it to not play again. Anyways, point being, In order for us to control our animations, we have to have an animator. It's the brains of the entire animation. This is part of their new animation system in Unity. It's actually quite powerful, but it adds another layer of detail that we now have to manage. So you got to have an animator. The controller is this door group. This should automatically get created for you. Okay, it's now an asset, so we got to have it. It's going to be created for us. So really, we need 3 things in order for an animation clip to be activated. We need to have an animator, a controller, and then the actual clip themselves. Okay, 2 of those things will automatically be created when you start the clip creation process. Okay. So I need to have 3 animation clips for this one animation. An idle animation where the doors are just closed permanently. When the player walks in and activates the trigger, we need to have a door open animation. Okay? And then finally, when he exits the collider, door close. So 3 clips. Let's jump back over into our animation timeline and start looking at how we're to do this. Okay? So welcome to the animation timeline. It's actually a really, really easy environment to load in and work with. The important parts that we want to look at, this section right here is going to show you a pull-down list of all the animation clips that are associated with the game object that you currently have selected. Okay? I only have 1, so we're only going to see 1 there. The samples is kind of like a frame rate. Okay? We also have the ability to add keyframes, and we also have trigger markers. This is kind of going back to what Taylor was just asking a second ago, that will allow us to activate some sort of external command when the playhead reaches to that spot. So I'll let you explore that. But in order for us to get this system going, we have to tell the computer what we're going to be animating. And these animation channels need to be the same on all 3 of our animation clips. So I need to know, and I think I probably can see, yeah, so I'm going to be animating my doors along their local x-axis, okay? So I need to load that in under the Add Property menu. Now, this is the transform of the group. We don't want to influence the transform channels of the door group themselves, but check it out. Here are the 2 children of that group. Here's door left, and I want to access its transform channel, so it's local X. So I want to keyframe some position information. I want to do the exact same thing for our door right. Transform position. Okay. Now for the door idle animation, we don't need to really do any keyframing. We just want them shut, but we absolutely need to have those keyframes in the timeline so that we have something to transition to and from on the other animation clips. Okay. All right, so that was the easiest one out of the 3. Let's make another one. Okay, and this is going to be the animation that physically opens the doors to our wall. So you can do it here in this pull-down menu, create new clip. I think this is probably the easiest way to do it. Let's give it a good name. Go ahead.
Don't you want to start the closed clip, because then you can start from the closed?
Absolutely. Yeah, for sure. For sure. I'm going to do door open. And now we need to do the exact same thing that we did on the idle clip. We need to expose the properties that we're trying to animate, which are the position channels for both the left door and the right door. There we go. And now we need to start doing some heavy lifting here. We actually need to start doing some animation. Now our timeline inside of Unity is very similar to timelines that we've seen in other applications. These little diamonds on the timeline are the keyframes. So right now we've keyframed in and we've preserved the current location of these doors inside of our 3-dimensional scene. It arbitrarily puts another set of keyframes way down here on the other side. I think that's probably good enough for me. I want my doors to open in about a second, which is pretty cool. So my playhead's on my final set of keyframes. Oops, excuse me. And now I'm simply just going to move them into the wall itself. Now I'm going to be mindful. I've just moved it 403 along the X. Okay. I'm going to do the exact same thing. Do negative 403. Well, it's not. My numbers are not the same on both sides. That's okay. I'm just going to do it visually. Let's play it. Oops, I forgot to key it in. That's my fault. My fault. These are not perfectly symmetrical objects. So there's two things that we need to do here, or we need to save the current location as a keyframe at the playhead. You can just key it like that, which is absolutely fine. Or, and this is a cool system, you can hit the record button, and then it's just going to record and automatically generate a keyframe on your timeline. So 6 to 1, half a dozen to another, however you want to make your keyframes. Let's play the clip. Cool, I like it. Now what we're seeing inside of our timeline, this is our classic dope sheet. So we're just seeing the indication of where the keyframes are inside of our marker system, our ruler, our time ruler. However, down here at the bottom, we have a curve section. So now we have a graph editor, and we can actually go in and start interpolating these curves differently, set easing in and easing out. It's pretty neat. We can actually change the values that we're keying in here as well. So we definitely get a really nice series of controls inside the animation window in Unity. All right, let's go back to the dope sheet because I think that's all we need. Let's just play it one more time. Excuse me, I clicked off of it. That's the idle animation, looking good. Here's the open animation. Cool. And you got to add the sound effects, right? Like the Star Trek door sound effects. Yeah, right? Okay. So we need one more animation clip. Let's do it real fast. Unsurprisingly, this is going to be door close. Okay. Now, door close, once I tag the properties that I want to animate, all right, now door close, I want the first keyframe to be identical to the last keyframe of door open, right? That way they're starting in the exact same, well, we're ending in one spot for the door open animation, and then we're beginning in that exact same spot for the door close animation. So we don't see any sort of jitter or a little bobble in there, right? So let's go back and figure out some numbers here. I want to return to door open, okay? And the last value on frame right there, so 405, I'm going to copy that. There we go. And now I'm going to go to door close, and I want that to be 405. And I'm going to key it in, make sure we've preserved it. I'm going to do the exact same thing for the other one. On door open, $704. Same thing over here. Why didn't that go anywhere? No, it did. It did. Let's key it in. Now, for whatever reason, I didn't do that one. I think it was 405, if I remember correctly. 4.05. Hit the return key. Hit the return key. There we go. Let's key it in. Make sure. Yep, there we go. Now I have it. So let's just really confirm it. Door open. Life is good. That looks the way it's supposed to look. If I look at door close, it starts open, and then they go back to their starting location. So mission accomplished. We did it. We have all three of our animation clips created. Okay. The next part is where it gets a little funky, because now we need to start blending in between each one of these animation states, right? Because we want to call each one of these animations to be activated upon a condition, right? And this is where it gets a little bit complex. I think the first time you do it, it's the hardest. But after that, it gets a whole lot easier very, very quickly. There are a couple little landmines that we're hoping to avoid stepping on. And I've been going for about an hour and a half. So now's probably the best time to take a small little break. And then we'll come back in and look at how we can wire in our animator to make it work. Okay, so right before we went to break, we just got our door animation clips rocking and rolling. This is looking pretty good. Now comes the hard work in wiring together the controls of our animator to physically make this work, okay? Now this is the part that's a little strange, and I'm going to go through it pretty slowly and the best I can to ensure that we can see the sequence unfold in front of us. Because we have 3 different animation clips, and we need to tell the computer when to play these animation clips and how they're going to blend between the animation clips. The area inside of our interface that's ultimately responsible for doing that is the animator. So let's go up to the top of the screen under the window pull-down menu, and under the animation section, we have access to our Animator Palette. Here it is. Okay. Now let's select our door group. Okay. And this is what we have. And I think I can actually zoom in on this. There we go. All right. So welcome to your animator. Okay. Now what we see in here are all of our animation clips. Okay. This is the animator. And if you don't see, if there's nothing inside of your animator, you want to go to your door group controller, animation controller. Okay. I think you can also click on the animator itself. Let's confirm that. I think if you just click on the animator or the door group, oops. Yeah, that's how I've always done it. I've always had the window open, and then I've just clicked on the group inside of my project tab or in my hierarchy, and it pulls it up. So just go to the game object that has the animator on it, click on it, it should load it into this window. So what we're seeing inside of this space are all of our animation clips, okay? And we also have some nodes in here that are really kind of mechanical. These are, the back end of the Unity database manages the entry and the exit stuff. In really complex animation systems, we can wire the entry and the exit states into other animators. It can get really, really deep very, very quickly. We're going to keep it simple for day one, okay? What we're basically creating here is a small little diagram that allows the animation system to transition between these 3 animation clips. Now the door idle, this is the default state. Now if door idle isn't orange for you, okay, here's how you fix it. You right click on it, and we want to set the layer as the default state. Okay, and that will make this one go orange. Okay, so this is kind of the initial animation clip that's activated when the game launches. Okay, naturally when our game launches, we want our doors to be in the idle animation clip. Now we want to make a transition between this clip and open, because naturally when our player walks into our trigger, we want to transition from this clip here to the open clip over here. The way we make transitions between these clips is simply by right-clicking on this one and make a transition. We get this little line that connects them together. And I'm simply just going to left-click on door open and lock it in. Yeah, so right-click and then make transition. I'm going to do it one more time between door open and close. So I have my door open animation clip selected. I'll right-click, make transition, and then I'm going to left-click on door close. If you look very carefully, the little noodles between these different nodes here have an arrow. That kind of represents the flow of information between all of these animation states themselves. That's a good visualization of how all of these clips are working together as a unit, as a system. One more time, we can go to door close, I'll right-click, and I'll make a transition back over here to door idle. And that's our little system. Pretty easy. When our player walks into the trigger, we transition from the door idle animation clip to the door open animation clip. When we go out of our trigger, we go from door open to door close, and then we return very quickly back to door idle. Okay, so from close to idle. Okay? So now that we've made the transitions, we need to start establishing some sort of system that's physically responsible for moving the animation engine from one clip to the next. Okay? Because it's actually really kind of neat to see this in action. If you hit the play button while the animator open, there you go. See what it's doing there? It's just automatically cycling between all of our animation clips. It does door idle, door open, then door close. And you actually see, look at my door down here. It's just opening and closing, opening and closing, opening and closing, right? We don't want that to happen. We only want it to transition to a specific animation clip when I tell it to, right? Or when the game, through code, tells it to. So let's stop the experience for a second here. Command P to stop the game. And let's start making some changes. First things first, I forgot to do this earlier, and for that I do apologize. I want to make sure that on the actual clips themselves, we want to turn off the loop for door open and door close. We want idle to loop over and over and over and over and over again, okay? But for open and close, we want to turn off their loop ability. I forgot to do that earlier, so I apologize. All right, back to the animator, because this is where we're going to spend the remainder of our time, okay? In order for us to create some sort of condition that tells the animator to transition between these animation clips, we need to create a couple parameters, okay? 2 of them, actually. And that's where this part of our interface comes into play, the parameters section. So we're going to add a trigger parameter. Now we can add, there's 3 other data types in here that we can access. We can do floats, integer values, we can even do booleans, we can check against an animation state. However, for today, we're going to keep it really, really simple. We're going to create simply what I kind of imagine as a broadcast message in a trigger. It's just a word. And then whenever the animation engine hears that word, we're going to transition to a new animation clip. Okay? So these trigger words are pretty powerful. I want to double click on the name. First one's going to be open. I'll need 2, right? I have another trigger state called close. Okay? All right. So whenever the animation engine hears open, it's going to go transition from the door idle animation clip to the open animation clip. And the same with going from open to close when it hears the word close. So we need to tell the animation system to listen for these words, okay? And we do that by clicking on the little transition line in between the nodes, okay? So that thing, see how it goes blue? Then over here in our inspector, we'll be able to set some of our transitions, okay? Or set these triggers, I'm sorry. And we do that down here in the conditions. We actually get a cool little timeline. You can actually see it blending between the 2 animation clips. We can extend this if we'd want. Yeah?
Can you explain why you might want to use a trigger over a bool?
Well, Booleans are true-false statements, right? We are. Yeah, if you wanted to look into that, do it. Go ahead. Experiment. We're going to keep it easy with triggers because they're just words, okay? And we can pass these words as arguments in between functions, which we're going to see here in a second. What you can do with Booleans, it's incredibly powerful. All right. So naturally, between the door idle animation clip and the door open animation clip, the condition that we want to listen for is open. So we're listening now. So when something says open, we're going to transition between these clips. We're going to do the exact same thing between the open and close. So this one right here, we're going to add in a condition, but we don't want the condition to be the open word. We want it to be closed. Now there has to be, there's one small thing that we need to do for the transition back to idle. And that's this exit time. We want to disable the exit time. That way, as soon as this clip finishes its evaluation, it just transitions. Okay, that's what we're trying to do. Right now, if you think about it, it doesn't transition between open and close until that condition's met. We want it to transition between close back to idle the moment that this thing is done animating. Okay, so it's going to go from this to this when it hears the word open. It's going to go from this clip to this clip when it hears the word close, and then it'll go from here back to idle the moment that this is done closing and finishing its animation. Okay? It's like an immediate transition back to idle. Okay? We're not waiting for that conditional word to be spoken. It's immediate. Okay? Well, it's actually not immediate. It's actually, if you look at the settings, it's actually a quarter of a second. But that's pretty immediate. So, all right. Anyways, So we've made our transitions between all of our animation clips. We've created a parameter that we now can use to transition, to physically move the animation engine from one clip to another. And now we need to access these parameters in code to tell the animator to actually do it. So we've created all the conditions, but we actually haven't told the animator to do anything yet, which is the next step. And we have to do this in code. It's the only way to get this going. Okay?
You're disabling exit time between door open and door close?
No, it's between door close and idle. This one right here. All right, let's go back over into Visual Studio and get this working here. So on my door controller script, this is where it gets kind of fun. All right, so there's a couple things in here that we need to do. We need to extend the power of this clip, because really all that we've done in this little bunch of code is just create the trigger. We're going into the trigger, we exit the trigger, we're changing a state based on that trigger. Okay, I'm going to get rid of this print command. Don't need that anymore. So now that we have all this working, let's start plugging in the animation stuff. Okay, much like we've done before, we have to go grab the animator that's connected to this game object. Because remember, this script is attached to the door group game object. The animator that's going to be transitioning between all these clips is also on the door group game object. So I need to load in my animator, this game object, the door group's game object. So let's make a variable so we can access it. It's an animator. And I think for the context of this, we'll just call it my animator, keep it simple. Okay. Much like we've done before in other scripts, the first thing we need to do when the game starts is load the my animator variable with some information. So my animator. What comes next? Pop quiz, hot shots. Get component, right? Get component, open and curly, or open and close carets, and then open and close parentheses. What's the name of the component that we want to load into that variable? The animator, right? We're trying to access the brains of the operation, the brains of the animation engine, which is simply the animator. It's a component on the game object. We're loading that in so we now can control it, okay? All right, so let's actually start controlling it here a little bit, okay? And much like we were doing earlier, we want to control my animator when the player enters and exits that little collider, that trigger system that we created earlier, okay? So here's the next part in this, okay? We know that somewhere in this function and in this function, we need to control our animator, right? But how are we going to do it, right? How are we physically going to go in and tell the computer to open and close, how are we going to tell the animator to physically transition between all these animation clips? Well, here's a great way of doing it, okay? An easy way of doing it, okay? So we're going to make another function. Okay, this function I'm just going to call door opener. Okay. As one might imagine, the purpose of this function is just to open the doors, right? If this is going to be where we're going to physically tell the animator to do something, okay? What we're going to tell the animator to do. So we're going to load in the animator. I saved that component in a variable called myAnimator. Now we're going to set the trigger command like that. So when we do myAnimator.setTrigger, we're telling it to, if you think about it, what we're telling it to do is to set these two, okay? We're setting these conditions inside the animator. When we set the conditions to open, it's going to transition. Remember, that little noodle, that wire, is listening. This thing is listening for that condition, that trigger to be said. Okay? Inside my script, I'm saying, open! So my animator's listening for that, and that's going to do something. Okay? So I could go in here if I'd like and do open, close. But there's another way that we could do this. Okay? Now that we have a little bit more comfort with some programming, I think now's a really great time to start passing some information from one function to another. Okay? We're not going to do an array quite yet. That's going to come. Those are pretty rad. But I need to load some data in here. I need a word. Okay? Check this out. This is going to be pretty cool. I'm going to create a variable. Okay? This variable is going to be a string variable, so just a word. And just generically, I want to put other. So this is just a generic name. Okay? Think of this kind of like a placeholder. Instead of hard coding in on this function what word to say, I'm just going to say, hey, take the word other. Just take the variable. Okay? Since a variable is a bucket that we get to fill with whatever we want it to fill, right? That's the power of variables. It's just a container. And then we get to fill that container with some information. Okay? Well, we gotta fill this container with some information because right now it's empty. Okay? Where we fill it is up here. So here's the void Ontriggerenter function. Now, in addition to flipping the switch, our Boolean switch from true to false, let's do this. Let's fill that bucket. Door open. So I'm calling the function now. I'm calling this function down here at the bottom. But I'm not just going to call the function. Have you ever wondered what those little parentheses are for when we call functions inside of an if statement or another function? It's a way for us to pass data from one thing into another. Okay? I think of this kind of like a teleporter on Star Trek. Okay? This is where the information starts, and it's going to go down there. Actually, in all honesty, it's going to go here. So we're going to teleport some data from here, and it's going to get loaded into the variable down there. Okay? This is where I write the trigger word. Okay? Since I data typed my variable down in the function to a string, it's expecting just kind of regular characters. Okay? That's all. It's just regular. This is a word. So I'm transporting this word down to here, which then gets loaded to there. Okay? Transporting it. We're going to do it one more time. So one might imagine we want to do the exact same thing down here. It's a way of writing the command once and then recycling that command, but changing certain parts of it given the conditions of the script. We're beaming data from one section of our script to another. All right, let's save the script and see if I've done this correctly. All right, rock and roll. I'm not getting any compiler errors. Let's test the game. Okay, rock and roll. Things are starting to look pretty good. My doors are closed. That's a good sign, right? The doors are in fact closed. That means the initial default state of our animation system was activated. Now when I get close to it, there they go, and then I just exited it really fast and they closed. So I went into the zone. I'm here somewhere. Oh, I'm still in it, by the way. Let's try it again. Oops, it's only playing once. Let's stop the game. All right, time to start debugging it because it didn't work the way I wanted it to work. Let's see if I'm actually, maybe I might not have actually passed through it. So I go through it once. Doors open. I exit. Oops, I hit it. Doors closed. I enter it again. So I got a problem with mine. Say again?
I got parameter other does not exist.
Okay.
Yeah, mine's also not.
Okay. Let's figure out why. So here's the script that I used. Okay. In your script, do you have any other Boolean that's called variable or other? No. Okay. Let's see what we got. See if we can figure it out. Ah, here's your problem. Look very, very carefully at how I wrote mine. Indigo had quotes around hers. Okay, we don't want quotes, just other. Taylor, you said yours wasn't working at all either.
Yeah.
What seems to be the problem?
I don't know. I'm not getting any errors. It's just not going.
Okay, so whenever you're interacting with an issue, remove variables. This is why we test as we go, so we know that all the small micro machines, if you will, are working together harmoniously. Is it your collider?
No, I left the debug logs in there just so I know.
So that's working.
So those are
Okay.
the thing that I'm approaching and then leaving the door.
You know, here's another cool thing, and this is something that I'm going to do to debug mine because mine is only firing off once. Okay, leave your animator open. You can see inside the animator which animation clips are currently working. Right. All right. So we just transitioned the door open. We just transitioned the door closed. Ah, look at that! It never actually transitions back to door idle. Okay, I got a problem. That's my problem. Yes, ma'am.
Mine seems to be ignoring the script. It's kind of just cycling through all of them.
Did you remember to turn off the loop?
Yeah, I did.
Okay.
If I'm in the collider, so if I'm out, it stays closed. But if I move into the collider, it opens and shuts it
Okay.
repeatedly.
Let's look at the parameters here, and let's look at the transitions between your animation states. Go ahead and stop your game. Okay, can you click on the little arrow, the white line between that one? Yeah, all right.
So open
So,
leads to door open.
door open, okay.
Door open.
Let's
to
close.
is close.
Cool.
And then this one is
You know,
it goes
I think
straight to
I
closed door.
think I messed up, and here's how I messed up. This is a good example of I can't walk and chew gum at the same time. I said it backwards earlier, and for that I honestly apologize. For the transitions between these two, between idle and open and close, these two we want to turn off as exit time, right? Because we're relying exclusively on the animation parameters to transition between them. And then for door between close and idle, we want to use the exit time, right? So it just automatically does it, which is going to solve my problem. It may solve yours as well. There we go. Idle's going, idle's going. I walk in, open's going, I walk out, and then it immediately goes back to idle. So I had it backwards earlier on mine. For that I apologize. Yeah, for
Between door open and door closed should have no exit time.
that's right. Yep. So between idle and open, no exit time. Open and close, no exit time. But between close and idle, we want to have an exit time because we want to rely exclusively on our exit time settings, this fixed duration, to transition this back to the idle pose.
Door open and door closed, it should be closed, right?
Between door open and door close, yeah, yep.
I can't figure out why.
Okay, couple things to look at. Case sensitivity is crucial in your code. So all lowercase on your parameters and all lowercase in your code?
Yeah.
Okay.
Are you go close to your door and just stand in your collider?
So we're not entering nor exiting.
Yeah.
Okay.
Enter into the collider, but don't keep walking.
Okay, hold on a sec. I gotta select my door group so I can actually see my collider. This will be fun. Okay.
Yeah, see, mine at this point just keeps doing a whole.
It's just looping.
Yeah.
Which one is it looping?
It's going through all of them.
Interesting.
I can watch it go up.
Yeah.
Up, and then back around in a circle.
I'm not sure.
I feel
We
like
can-
it's not listening to the script.
It's not listening to it.
Or maybe
Okay.
it's listening to it wrong.
Okay.
I'm not totally sure.
start eliminating variables. Okay, is it the animator that's causing the problem, or is it the trigger that's causing the problem? Places to start looking.
Don't you require all of them to be able to tell when something's happening?
Yeah, but we can eliminate them from the equation and still try to figure, and we can still create a system that allows us to test if that micro machine's working, right? Just like we were doing earlier. You know, you may just want to turn your animator off on your door group, okay, and then return to your script. And you know, are you changing these Boolean states? Are you able to do that? That's a good way to test, okay? And this is the kind of the thinking that we have to employ when we're solving problems in this kind of environment, right? There are a lot of different things that are at play, that are physically working. When the machine breaks, you got to figure out which part of the machine breaks, right? It's like if you go to a car mechanic, the worst thing you can say to a car mechanic is what?
I don't know how to fix it.
That's pretty bad too, right? But you shouldn't be expected to know how to fix your own car.
That you don't know a lot about cars and whatnot, 'cause then
The worst thing you can say to a mechanic is, my car's not working. Why is that the worst thing to say to a car mechanic?
It says nothing.
It says nothing, right? It could be anything. It could be the radio, for all they know, that's broken, that's not causing your car to work, right? Because in your perception, right, the radio not working could mean to you that your car's broken, right? Got to get more information. You got to figure out the details of the problem, and that hopefully will give you this solution. Yes, ma'am.
Is there a way to print what the current the other is basically, like in the last, so we have door opener, spring other. So that I can see whether that's good.
One way,
Before
yeah.
the-
Let's see, we do get these radio buttons. Yeah, and mine's no longer working. I must have changed something while I was talking just now. What did I change?
It used to get stuck on the did, no, you're still with the entry. Entry is still connected to.
Is there a using function if you press in the door controller?
I'm sorry, can you say that again?
Using function?
A using function.
Very, very top of the script where it says like using and then you can.
Oh, no. Yeah. Oh, I know why it's not working, because I turned my animator off. That's why.
So close isn't even lighting up.
Okay.
Open is lighting up and off.
All right, so now I'm working. Okay. Hold on 1 second. I'm trying to answer one question. You're giving me two more before I have a chance to answer your first one. Okay, so what I was going for, I was hoping that I can't do it now. Oh yeah, I can't do it now. I was hoping that these radio buttons would light up when those conditions are being met. They're currently not. How to expose those? Yours are lighting up.
Yeah, but only the open.
Ah, okay. So let's go back. Did you do Boolean or did you do trigger? Okay. I don't know. Yeah. I don't know. We're about to go into lab here, and we can see if we can bang on this and find a solution for it. Okay. All right. Final thing. Let's add it all together here a little bit. Okay. Because the big picture for today was to get some animation clips working. It's working for me. The last thing, or the other thing that we talked about, was sound effects. Okay. So here's the question: how are we going to add a sound effect when our door opens? Let's think about the logic first, and then we can go into the actual construction of the code. What do we need to produce for our door to open, or for our door to have a sound effect when it opens? So we need to have an audio source. Absolutely. What else do we need? Remember, there's three things that you have to have in order for an audio file to work.
the actual audio file itself.
Yeah, you got it. What's that called in the Unity sense? A clip. So we have to have an audio source, an audio clip. What's the third thing? A listener. Okay, a listener. A pair of ears. Now, our first-person rigid body controller has the listener already on it. Yeah. You can see it. It's docked on the main camera. There it is. So that part's mission accomplished. Now, I need to create some sort of audio source. I think I'm going to do that on my door group. Okay, so let's get that working. audio source, okay? Leave the rest of that stuff alone. Well, let's start figuring out the code in all this, okay? So we know that we're going to need to have some sort of function that actually plays the clip. We're also going to need to reference the audio source game component, just like we did earlier, and we creating it as some sort of generic variable that allows us to interactively change the audio clips is also, I think, a really great idea. Now, we've already done this in the coin destroyer, so in every sense, I'm just going to copy and paste a lot of that structural data from one script to another, okay? Because it really is, oops, went the wrong one, identical, okay? So I'll go back to coin destroyer. Here's all the audio stuff. We're going to do the exact same thing. There it is. I'm going to copy this function down here. Save my script. I think I got it. Oh, we didn't actually tell it to play the sound. So when do we want it to play the sound? Probably when we open the door, right? Let's do it. Awesome. All right. Save the script. Go back into Unity, and start populating that script with all the audio clip stuff that we need. All right. So here's my door group. Here's the door controller script. I'm going to place my audio clip in there just by dragging and dropping it. I think I'm going to use the whistle. There we go. Let's see if it works. Wonderful. Unfortunately, I don't have a sound effects where it goes when I exit, but it works, right? It works. There they go. I could do that all day, by the way. Okay, I got to stop with my little toy. Yeah, right? App Store, here I come. I'm going to be a McDonald's dollar air, right? You guys remember that commercial? Dollar menu air, that's what it was, dollar menu air, yeah. That's going to be me. Because that's how much this game is going to give me, exactly $1. All right, so there it is. We've gone the full circle. We've added audio clips, we've attached them to audio sources, we've activated them, we've created animations, we've created a script that controls the transition between all those animations, and we've created a really great, actually 2 functional game mechanics in a very small, short kind of a level, which is pretty cool. Neat, huh? Pretty neat. You guys like it? Awesome. All right. Pretty cool. There's one other thing I wanted to show you guys. Let me save all this stuff, because I'm actually going to close this down. I honestly have no idea. Oops, sorry. Save scenes, save projects. Someone asked earlier, can we bring in animation clips from Moto? And the answer to that question is yes, absolutely. Animation clips come with our project files if we want them to. I have a project file here that I've been working on for a long time. I'm nowhere close to it being done. But since we're thinking about animation, I wanted to show you guys a way to get animations from Moto over into Unity, because it's actually really easy. Okay? I think someone asked for, I think it was Rob asking about complex door animations. You can do some of that stuff over in Unity. Sometimes it's easier and faster to do it here in Moto, depending on how you've done or what it is that you're trying to do. So it's incredibly contextual, but you can do it. Let me show you what I'm talking about. As with everything, I'm just going to create a simple little cube. Okay. Of course, Moto's animation system is all item-based. Let me get rid of this. Okay. All right. So there's my little cube, and I'm just going to create the worst animation known to man, which is simply going to be, rotation. There we go. So I'm going to rotate my cube over the course of 60 frames, negative 360 degrees. There it is. Cool, huh? Riveting, I know, right? Here, let's have some fun with this. What's going on? Oops. There we go. Oop. Why are we all locked? Doesn't want to play nicely today. All right, well, I won't go in and mess with this because I don't want to make this longer than it needs to be. So I have my animation clip, okay? We can export this out quite easily, both the geometry and the animation clip, okay? They're never going to be unlinked from each other because the animation clip is always, almost kind of by law, required to be associated with some geometry. Really what we're doing is that we're not saving out the animation channels, we're saving out the vertex locations for all the verts on this small piece of geometry. And that's how our animation clip system works. There's one change that we need to make to our preferences to ensure that this animation data is exported, okay? And it's in the FBX IO properties way down over here. Because the FBX file format's pretty great. It can do a lot of things. It can export a lot of data from our apps over into Unity, but we need to make sure that naturally save animation is turned on, okay? There's also some properties down here at the bottom, sample rate, okay? We're going to keep it at just basically at the frame rate of our timeline, but you can change it a little bit, which is kind of nice. So you got to make sure that save animation's on before all of this jazz is going to export. I believe save animation is off on some versions of Moto as part of the default configuration. So just triple check it. All right, let's export this bad boy out. Save it out as an FBX 2018. And let's call this cube. Let's jump back over into the Unities and get this asset in. Now let's put it in my assets. All right, so a couple things in the inspector that we need to look at, because we need to ensure that the actual import animation's on, okay? So that's pretty cool. Here, check it out. There it is. There it is. But it took all 120 frames of my timeline. Boo. Okay? So what it grabbed is the sequence end setting here. Let's just change that real fast. I know that I'm only animating within 60 frames. Let's export it again. Same name, same file, same location. Let's delete this thing. Re-import. There we go. Now if you look down over here and take one, the end value is the same. So something to consider. It's going to take whatever's in your timeline, however long your timeline ends, that's how long this animation clip is going to be. We've got to manage this very directly. Okay? Got to manage this. All right. This is starting to look pretty good. I'm happy with this. Let's drag this into our game. So here's the cube that came from Moto. Okay. Now if we were to play the game, maybe I should, okay. The sound effects throwing me off, which is great. It doesn't initially start on at the beginning of the game, okay? Which is good because we don't actually really want it to start at the beginning of the game. So we need to go in and tell the computer exactly when to begin this animation. The clip is there, right? And now we're in a whole series of things that could that we can control, okay? So do you want it to just be on when you start the game? Maybe. Okay. Do you want it to be called, you know, at a specific time? Maybe. So this is when we got to start testing it out. But the animation did come along for the ride. You actually get a preview of it. So it does work exactly the way we had over inside of Unity. One of the things that you can do, if you just simply want to have it play at the beginning, just play and play and play and play. Let's see. Here's the cube. See, it doesn't have, it's not loading in the clip at the moment, which is why it's not playing. See how it says none? There's no controller in here. It's looking for some sort of rig. So if we go back to the animation set, let's not do, let's do none. See what happens. Does it strip out the animation clip? It did. So we don't want that. Yeah, and since I'll have to re-import the asset to get the animation clip back into the system. So don't, I think it's legacy. I didn't want none, I wanted legacy, which it will just, the legacy animation system will just play a clip. It's kind of like the most unintelligent animation system on the face of the planet. It just plays something. You don't get any control over it whatsoever. It's like from 1.0 of Unity. It's pretty bad. But if you just want something to play without having to program it, that'd be a good place to begin. Let me do this. This is a great way of re-importing that asset as a hack. So assets folder. So now I'm going into the actual asset folder themselves. There's the cube. This is the one on my desktop that I saved from Moto. I'm just going to replace it with the file that's in my asset directory. Let's see. Is it going to completely refresh it? It's not, so I got to re-import it. Boo. Boo on you. That's no fun. Let's refresh it. See if it will bring back in the settings. There we go. Actually, it did. Haha, great. Let's do legacy. Apply. Yep, now it's working. Now the animation clip's there, and it's just going to play. Yeah, see how on the legacy animation system, there's no animator. It just plays a clip. We can tell it to play automatically or not. This is the easiest way to get something just to play its animation clip. And there it is. Yeah, because it's going back to the root location of the object itself. So it's basically going back to the origin of the scene because that's where I animated it in Moto, right, at the origin. Because when we save an animation clip, it saves the vertex locations. That's all it's doing. It's just saying, hey, this vert is at this location, and then on the next frame, that same vert is on this location. It's just saving vert locations. That's all it's doing. It's pretty unintelligent.
So hypothetically, if you were to pair it like items to like animated cube, it wouldn't rotate, would it?
Let's test that idea, right? So I have a cube. What if I was to take an empty game object and parent the cube on it? Is this what you're talking about?
Opposite, actually.
Opposite. Hold on 1 second here.
Now, I'm curious, if I were to, say, animate a door with an opening sequence, would I have to make that door in every place it needs to be? Or is that just a specific, the specific way it,
Yeah, so the way we get around it is by parenting the animated object to an empty game object, right? Yeah. That empty game object is just serving as a place, sorry, I should turn that sound effect off.
You did that on purpose.
That was on purpose. Yeah, so we parent it to an empty game object, and then wherever that game object goes, the cube will also go. The cube thinks it's still kind of in its original location, okay? So it's not going to jump back to a certain spot in the scene. Yep. And if I just wanted that animation clip to loop over and over and over again, let's see. Animations. Yeah, I'm trying to think why it's not giving me the ability to control it. Oh, the wrap mode, let's just do loop. There we go.
What's your favorite animation program, Pat?
I can't answer that question. There's
Is After Effects compatible with Unity?
That's not, because After Effects is just, and that's just an entirely 2D animation package, yeah.
But what if you brought 2D and you're making a 2D game? Would you?
Different. The 2D animation pipeline inside of Unity is all sprite-based. It can be clip-based from time to time, but for the most part, it's going to be sprites. And I don't have a lot of experience working with sprites. I just do 2D, or just do 3D. I don't do much of 2D stuff anymore. So now I got to loop, which is pretty cool. This is a simple example. I don't know how my complex example is going to work, so bear with me just for 1 second. This may not go well. I'm working on something. I don't know how this is going to happen. So this either may work or it may not work. It's also going to take forever to initialize because I got about 800 textures on this thing. Some of you guys have seen me working on this here and there, and I'm about 40% done. So I have a long way to go, but it kind of shows that you can take really complex animations and from any app for that matter. It doesn't matter if you're doing this in Moto, Maya, Cinema 4D, it doesn't matter. The export process is the same. Here we go. Yeah, so this has been my little pet project for a while. There we go. So there's a lot of animation going on in there. A lot of spinning globes. There was a period of time in my life where I was just making spheres. That's all I was doing for like a month. Yeah, so. You had a question, Kevin?
Yeah, how many computer resources do you think animations take up?
It depends on how many verts are on the mesh, okay? Because remember, with an animation clip, it's just analyzing the location of the verts. So if you have an object, like a character that's got like 80,000 verts on it, the animation clips are going to be quite heavy because that's 80,000 verts it's trying to manage and remember each frame of the animation clip, right? Versus a cube, which is going to have 6. So it's starting to look pretty good. I'm pretty happy with this. This was a test for me to see if it worked. This is always fun. Go right through it. Pretty fun. Does anyone know what this is from, by the way?
Dark Crystal.
It's from the Dark Crystal, yeah. I hope that they are. They've been talking about it for a long, long time. They're going to do a Dark Crystal remake or a television series. Every year, there's someone seems to make an announcement that they're trying to reboot that franchise, and I'm all for it because I think the Dark Crystal was pretty great. It's one of my films, as they say, up my alley. And this is one of the big set pieces in that film. Yep. And there are so many parts on that damn thing, right? Someone asked me last week or the week before about cloud storage. And I think I mentioned in that conversation that you put irreplaceable files in the cloud. Because when you save something to your Google Drive or your iCloud, wherever, you're actually saving it to about 2,000 different hard drives across the entire globe. If your house was to burn down, you still wouldn't lose your data, right? And there are irreplaceable files. This observatory, for me, is irreplaceable. I cannot go back in and redo that model again. I will not go back in and redo that model again. It's just too much stuff.
You should send that in.
What's on the base of the
The floor? Yeah. It's a texture that I made. This is I'm very not close to finishing this at all. This is just kind of a first draft of the textures and the environment. But in the actual,
This is a first draft?
Yeah. Doesn't even have any of the props in there yet. I have about 8 tables, a half a dozen chairs or so. I have about, I think I have about 7 or 8 like different glass jars, a telescope. I mean, if you look at the film itself, this environment is full of just stuff. And I've systematically started to model each one of the props from the film, and that will go in here in the next round. In the film itself, they have this gigantic texture on the floor, And I have a book at home. It's The Art of the Dark Crystal. That came out probably 10 years ago or so. And I got lucky because they had the original artist and the concept designer for the film provided that image. And I took a picture of it. I scanned the page and I traced it in Illustrator. I made a 2D vector file of the entire texture, and then I threw it through our art pipeline, and it's looking okay. I got some resolution problems that I'm still battling at the moment. It's a little fuzzy for me. I got to go in and fix that, but it kind of works. Yeah, I got some specularity problems that I got to dial. A little too shiny for my tastes. Yeah, see where it's getting all jagged there in these small lines? I need to get, that's a resolution problem. So.
Where did you animate that? What program did you use to animate that?
This is all Moto. Yeah, all Moto. But I'm not doing anything that's Moto specific. This is basic transforms. It's just a complex machine with all these weird angles, and there's pieces that need to rotate in very specific yeah, to get it all to work exactly like the film.
The creators of the Dark Crystal and be like, I'm your biggest fan. Maybe they'll send you like, I don't know, like some tickets or something to the new movie coming.
That would be awesome, right? Do you need a model of the observatory? Because I'm done. Yeah.
An email later. Hi, would you like to work for us?
Yeah. No, I think this is probably as close to a one-to-one recreation of the actual set piece itself. That was my favorite part of the film. It still is my favorite part of the film. So I wanted to do an homage to it. The textures are a little bit different. The colors I kind of saturated a little bit more. I kind of took my own artistic liberty on the colors. In this is just a temporary 2-point lighting setup. It's nothing too fancy. The lighting's really, 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 really bad. But you can kind of see that I saturated the colors. In the film, everything is very, very desaturated. It's got this heavy, heavy patina on it. And they're supposed to make it look like a 2,000-year-old piece of machinery, right? So it should look like it has, a heavy patina on it, but I didn't want mine to look like that. I wanted it to be a little bit more saturated with colors.
Have you rendered something out in Moto?
No, I haven't. I haven't even thought about it, in all honesty, mostly because it would just take forever. It is a Moto project file. I don't have that with me. I just have the real-time version of it. It started in Moto. I actually have a sub-D version of this, but I just know with all those textures in there, it's just going to take 1,000 years to render it, and I just don't want to deal with it at the moment. So maybe someday. Someday.
It looks great inside of Unity.
It would look amazing instead of Moto, right? You'll see this again towards, in 3 or 4 weeks or so. I want to talk about some advanced rendering ideas instead of Unity. We're going to use this as an example file in there, like reflection maps. What you're not seeing in here is reflection maps. These are just coming off the textures and the lighting. So it's not doing any sort of really significant reflections of the environment or itself. So things are going to change pretty drastically once we start getting those reflection probes in play here. They'll come to life, as they say. And reflections are just about the most difficult thing you can do instead of real-time rendering. It takes a tremendous amount of resources, and I mean a tremendous amount of resources. Last year at Game Developers Conference, Unreal had a great demo of Captain Phasma and a whole bunch of stormtroopers dancing around a chrome set, and they were showing off the real-time ray tracing capabilities of the Unreal Engine. It's a great demo, right? And it's super exciting to see that level of photorealism on reflections happening in real time. And then, yeah, yep.
You can see like as the lights pass out, you can see them.
The reflections changing. I mean, it's everything that you want to be, right? A couple months after Game Developers Conference, someone was talking with the artists about how they made that demo. And like, yeah, the one thing that we didn't actually happen to tell anyone during the keynote is we had like a $20,000 machine in the background that had like 8 GPUs on it to get the real-time reflections and to get it at the frame rate that we wanted. So not exactly a commercial grade product yet, but it shows you where we're going, which is pretty cool.
We could finally actually like put mirrors in video games and have them work.
Yeah, no, that's in our future, very, very closely in our future. All right, enough of this. enough of this craziness. Yeah, that's it. That's all I have, by the way. Just that. There's going to be a road going down here in a second. Anyways, all right. So we got about 30 minutes left in class. Let's use this time to start finishing up our game. Because remember, we have a turn-in next week, and we get a lot of programmed elements that we need to include, so let's use our time wisely. Okay? Let's get to work.